Hello and welcome to my YouTube channel. Today we will be discussing about the mean of the sampling distribution. So before anything else, let us first define or be familiar with the terminologies that we're going to tackle. Okay, when we say population in statistics, it is a collection of subjects that has common characteristics. Okay, example, if we want to determine the mathematical ability of the grade 12 students, you need to, or the subjects here are the grade 12 students, since their commonality or the common characteristics is being the grade 12 students. Then suppose that your population is too large, like for example, if your population is consist of the grade 12 students, then you cannot, or you don't have any time or resources to survey or conduct survey to those students. So you need to have a smaller number of students to conduct the survey, and that is what we call the samples, or and every element is what we call a sample. It is basically a part of population that contains the characteristics of it, or the population. Then when we say sampling distribution, this tells us the characteristics of the samples taken from a population. So in every samples that we're going to take, there is what we call characteristics that will emerge from it, and one of those characteristics is what we call the mean. And let us explore now on how to determine the characteristics of every sample or sampling distribution. Okay, example, if we have a set of numbers, we have a set of numbers containing 2, 4, 5, and 8, and this one is, shall we say, let's call it a population. And suppose we'll take 3 samples from the population from these 4 numbers. So let us create or solve for what is the mean. We will now solve for the mean of sampling distribution. Okay, the first is to identify or to use this formula of the combination, which is in the combination of n taken r. So using the calculator for the combination, so we will just plug in 4, since we have 4 elements of the population, and we will take 3 samples from it. So then 3, then pressing the calculate, so we have 4. So meaning to say, we will be allowed to have only a maximum of 4 combinations if we take 3 samples from these 4 numbers. So basically, the first number will be 2, and we can also have 5 respectively for the first set of samples. Next, we can have 2, 4, and 8. 8. Then we can also have 4, 5, 8. 4, 5, and 8. Then lastly, we can have 2, 5, and 8. 5 and 8. Okay, the next step is to determine the mean of these samples. So in the first row, so we have 2 plus 4 plus 5 equals 11, then divide by 3, since these are composed of the 3 numbers, so we have 3.67 rounded off to the nearest hundredths or 2 decimal places. Next, we'll have 2 plus 4 plus 8, so 2 plus 4 plus 8 is 14, divided by 3 is 4.67. Then 4 plus 5 plus 8. 4 plus 5 plus 8 is 17, divided by 3 is 5.67. Then lastly, we have 2 plus 5 plus 8. 2 plus 5 plus 8 equals 15, divide 3 is 5. Okay, next, since these combinations has the same probability of being chosen, so we will write 1 out of 4 in every 1 out of 4 in every row. 1 over 4, 1 over 4, 1 over 4. So let me first format this one into fractions so that we'll have an idea that this is 1 over 4. Next, let us convert 1 over 4 in decimals so that we will have a shorter time, or we will have an easy way in computing for the mean and the probability. So we'll have 1 divided by 4 is 0.25. Then we'll just copy all of the probabilities since they are equal, so the decimals also are equal. Next is to multiply the mean, this column, to the probability in decimal places. So we have 3.67 times 0.25 is 0.9175. Next, 4.67 times this 0.25 is 1.1675. Next, 5.67 times 0.25 is 1.4175, and 5 times 0.25 is 1.2500. Then to get the mean of all means, so we will just simply, or the mean of the sampling distribution, so you will just add these numbers. So I'd like to use the auto sum, or you can also manually type in those numbers. So using the auto sum, so we have 4.7525, or in 2 decimal places, if we're going to convert this to 2 decimal places, this will become 4.75. Now let us now compare the population mean and the mean of the sampling distribution, if we can have or generate a conclusion from this. So let us add 2 plus 4 plus 5 plus 8. So 2 plus 4 plus 5 plus 8 is 19, divided by 4, since we have 4 numbers. So the answer is 4.75. So in other words, the population mean is simply equal to the mean of the sampling distribution, if and only if the samples are to be selected randomly. So that's it. That's how we're going to solve for the mean of the sampling distribution, and also we have just concluded that the population mean is equal to the mean of sampling distribution. So comment down below if you want to know more about topics related to statistics and probability, and be sure to like, subscribe, and hit the bell button to get notified with the future uploads. Thank you.